Today, let's focus on finding the domain and range of a function. Given a function y equals x, we know the domain is the set of all possible values of x, and the range is the set of all possible values of y. If the graph of function is given, it is easy to figure out the domain and range. Let's look at the first example. You see the minimum value of x is -3, but the maximum value of x on the graph is 4. Since it is continuous, so every value between -3 and 4 is in the domain. So the domain is -3. We use a square bracket because this point is inclusive. And 4, we use round bracket because 4 is not inclusive. Similarly, y starts from -2 and goes up continually to 3, not inclusive. So we know the range equals -2 and 3. Now let's look at next example. We know the minimum value of x is -1. And the maximum value, look at the arrows, it means infinity. So we know the domain D equals -1 and infinity. For the y value, y goes up continually to infinity. So we know the range is 0 to infinity. If the graph of function is not given, or it is hard to graph the function, how to find the domain and range? Well, we can use algebraic way to find the domain and range. Let's consider domain first. We consider 3 cases. If there's no restriction for a function, then we know the domain is the set of all real numbers. We can also write as -infinity to infinity. For example, all linear functions at y equals mx plus b, or quadratic functions, say y equals ax squared plus bx plus c. In general, all polynomial functions have the same domain, -infinity to infinity. Next, if the function contains a denominator, we know denominator cannot be 0. So using this, we can figure out the domain. Let's see. Y equals x over x plus 1, x minus 2. We know when x equals -1, the bottom equals 0. When x equals 2, the bottom equals 0. So the domain for the function should be x is real number, but x cannot be -1 and 2. If a function contains square root, so square root a or fourth root of b, in this case, we know a, b must be non-negative. So let's see example. Y equals square root of 4 minus 2x. We know 4 minus 2x must be greater than or equal to 0. To solve x, both sides subtract 4. So we get subtract 4. So we get negative 2x greater than or equals negative 4. To eliminate negative 2, both sides divided by negative 2. So negative 2x over negative 2, the right side, negative 4 divided by negative 2. Be careful. In this case, we must change the direction to less than or equal to, because we divide a negative number. And you see the left side equals x, the right side equals 2. So the domain should be real number, but x less than or equal to. Next, we consider range. To find the range, the key idea is to make connection between x and y. I show you a few examples. First, let's consider a quadratic function. So y equals negative x minus 1 squared plus 3. We know the square of any number should be non-negative. So we get x minus 1 squared greater than or equal to 0. Now we want to create a function. So first, both sides are multiplied by negative 1. So the left side equals negative x minus 1 squared. The right side, negative 1 times 0 is still 0. But we need to change the direction. So less than equal. And then we add 3 to both sides. So we get negative x minus 1 squared plus 3 less than or equals 3. And we know the left side actually is y. So y less than or equals 3. So the domain, the range is y less than, y is a real number, but y less than or equal to 3. Let's look at next example, a square root function. So y equals 4 square root of 2x minus 1 minus 3. We know the outcome of square root should be non-negative. So we get square root of 2x minus 1 greater than or equal 0. Both sides multiply by 4. So we get 4 square root of 2x minus 1. The right side is 0. We keep the same direction. And then we subtract 3 to both sides. So we get 4 square root of 2x minus 1 minus 3. The right side 0 minus 3, negative 3. So this one greater than or equal to negative 3. Again, the left side actually is y. So y greater than or equal to negative 3. So the range for this function is y is a real number, but y greater than or equal to negative 3. Let's look at our last example. We consider a rational function. Y equals x squared minus 1 divided by x squared plus 1. First, we change the numerator to this way. So I write as x squared plus 1 minus 2 over x squared plus 1. And then I write as two fractions. So x squared plus 1 over x squared plus 1 equals 1. And minus 2 over x squared plus 1. We know x squared plus 1 greater than or equals 1. Then we get 1 over x squared plus 1 should less than or equal to 1 over 1. We know 1 over 1 equals 1, but 1 over x squared plus 1 should be greater than 0. So we focus on this one. Now I want to create 2, so both sides actually are multiplied by -2. So 0 times -2 gets 0. This term multiplied by -2, so we get -2 over x squared plus 1. The right side equals -2. We need to change the direction because we multiply a negative number. So let 0 greater than this term, and this term greater than or equals -2. To create a function, we need to add 1 to each part. So I add 1 to 0, so I get 1. The second term, I add 1, so I get 1 minus 2 x squared plus 1. And -2 plus 1 equals -1. So we know that one is y. So that means 1 greater than y, but y greater than equals -1. So the range of the given function is y is real number, but -1 less than or equal to y, but y less than 1.